I work at an organization called America Makes. And America Makes is the National Additive Manufacturing Institute. It was started by the Obama administration in 2012 with a mission to advance and accelerate the adoption of 3D printing and additive manufacturing technology in the US. And it's a public-private partnership. It's funded by the DoD, but we have partners from across industry, academia, and nonprofit organizations. And many of you may actually already be members of America Makes through your companies. So we're actually also part of something called Manufacturing USA, which is a national network of the Institutes for Manufacturing Innovation that focus on different technologies that you'll probably hear about over the next couple of days, things like robotics, advanced flexible hybrid materials, and yes, the very most recent institute is around bio 3D printing, so 3D printing of organs and things like that. So, 3D printing. At this point, if I asked everyone to raise their hand if you've heard about 3D printing, I'm pretty sure everyone's hands would go up, right? It wasn't always that way. It used to be about 30% of the room, but by now we know that 3D printing is a layer-by-layer additive technology that allows us to design in the cloud and create a 3D digital item. But I want all of you to think about right now, just in your mind's eye, I want you to imagine. Imagine something that you could 3D print, whether it's on your body, if it's in this room, it's in your home, or it's in your companies. I want you to just get that picture and maybe sketch it down or write it down, because we're going to come back to it later. Has everybody got something? OK. So I don't know if you recognize the person on the right, but that's me. And I used to say when I first started in the 3D printing industry, I not only drank the Kool-Aid, but I made it and I handed it out to everybody. And I was particularly excited specifically around digital local manufacturing hubs and this idea of online digital stores. I thought, this was happening immediately. And I was really excited because I wanted to make umbrellas. So when I first got to the 3D printing industry, I was in Chicago. I go to the Innovation Hub. I have this design for an umbrella that's not going to turn inside out by the rain, that's not going to break, it's not going to poke you in the eye, that's made with recycled, ocean plastic. It's completely 3D printed, and it's got an embedded sensor in it, so if you lose it, you can find it with your iPhone. And I thought I was going to print that. I was going to prototype that at the Innovation Factory. I was going to print it on a desktop 3D printer, and I was going to mass produce it at these digital manufacturing hubs all around the world. So no, I wasn't, right? My bubble was burst, like many of us, because at the time, the technology, specifically, the speed, the cost, the price of the technology, the materials, the strength, they just weren't there. However, we're now seeing that there's this graph that looks at, kind of the peak of inflated expectations. So I was drinking the Kool-Aid right around 2010, 2012, at the peak of inflated expectations. We went through this trough of disillusionment with this idea of 3D printing in the consumer world, kind of crashed a little bit. But now where we're at in 2017 is we're beginning to be at the slope of enlightenment. And we're there because a lot of 3D printing manufacturers are starting to really make good on these promises of moving from prototype to production. So this is a really good example. It's Fast Radius. So Fast Radius is a global 3D printing distributed manufacturing company, and it's partnered with UPS. So they have hubs, and in those hubs, there are 3D printers from across multiple different technologies, and you can give them your file. They're open till midnight, and then their UPS then goes at 8:30 a.m. and will take your thing that you printed at midnight and send it to you by 8:30 a.m. the next morning. And what they've noticed is that for 3D printing, products that are highly customized and highly valuable, but in low batch, have been really successful, so especially in the medical industry. They're also starting to see the value of customization, so they're working with a company around earbuds. They're going to make 250,000 customized earbuds over the next year. The idea is that you have an app, you scan your ear, and so it won't fall out. It's just for your ear if you're doing yoga or you're running or you're going to the gym. They're also looking at customers who are talking about, inventory. So how do we start thinking about how to have inventory in the cloud? Because now we have 900 regional hubs in partnership with UPS. We don't need to hold inventory anymore. We can have our inventory in the cloud, and we can print it on demand in our regional hubs. So at Rapid this year, and Rapid is one of the big 3D printing shows, I'd like to say that we begin to starting to see this curve of enlightenment that we're moving from fiction to factory floor. And again, it's really about these new 3D printing companies and also legacy companies that are starting to advance the barriers that had been holding us back from kind of achieving those imagination that we had. And so what we'll talk a little bit more about today in the next couple of minutes is why use 3D printing, what are some of the newest technologies and advances that are currently happening, how are companies and industries using 3DP, and how do you begin to think about how you might want to use it in your company? And then also this integration of exponential tech. So that's really where the power lies, is in combining and converging advanced manufacturing and exponential technologies and mixing them together. So why? What makes this technology not just evolutionary, but revolutionary? And I'd like to say that it's kind of 3 core C's. So the first is that it's very complex. So because we no longer have to rely on designing for cost, we can design for function. So we can start designing products that we couldn't do in any other way. We couldn't injection mold it, we couldn't CNC it, we couldn't form it. Things like using lattice structures, biomimicry, generative design, where an algorithm actually creates the design for you. And using those design advantages to lightweight our products, to customize our products and optimize them, and then to see cost reduction, energy efficiency, fuel reduction. The second is that it's customized. So who's heard about Invisalign braces? Every single Invisalign brace is 3D printed. Why? Because it needs to fit directly to your teeth. So customization is a great place that we can use 3D printing. The dental industry is now starting to look at dentures. Materials have evolved, and now we can do 3D printed ceramic and ceramic bone. So as the materials evolve, we can customize new things. And it's a one-size-fits-none model, right? Where it's about small batch productions, and it creates a unique user experience, but it's been used a lot in the medical industry, I'd say the most, for things like prosthetics or customized implants. I think just a couple of days ago I heard we're now 3D printing cartilage. And the final is the cloud. So the cloud also kind of connects with cost as well. So because you don't have to make things in molds, you can just design it on your computer and print it on your printer. It allows for rapid iteration. You can make quick prototypes. You also can have reduced inventory, as I kind of mentioned with Fast Radius. And it's also a cool tool for collaboration. There's people who are designing and co-creating on the cloud from New York to Nepal, creating new 3D printed shipping containers for a resource center for disaster relief. So why use additive? Well, at America Makes, we had a session with about 30 different experts wanting to understand why they were using additive within their organizations. The why is really important. It's the beginning of understanding the how. Understanding whether or not you're going to use this for product innovation, for cost reduction, for supply chain efficiency is a key to understanding what technologies you're going to use, what materials you're going to use, how you're going to train your workforce. So what's new? There's a lot of things that are new. I will say that just this morning I woke up and it turns out we have 3D printed a mouse ovary, and that mouse has given birth to babies. So we could talk probably all day long about all the new things, but I just want to focus a little bit on the industrial manufacturing newness and how we're really moving from this idea of prototype to production and making the factory real. So carbon, many of you are probably already familiar with the clip technology. Desktop Metal and HP, I kind of call them the new kids on the block, and they've done a lot around speed and cost. Carbon now can, using light and oxygen, emerges a part that comes out 25 to 100 times faster. Desktop Metal at Rapid was just showcasing they have both a studio and a production system. So the studio system is a metal desktop 3D printer that you can use for your engineers. It's low cost. And their production system is 100 times faster than previous metal systems. So that's incredibly fast in comparison, and it's also much less the price. HP is also looking at multi-jet fusion and expanding around polymers. And they also have open source materials, so it means that you can really advance this technology by keeping your machine open sourced. 3D Systems and Stratasys are both thinking about integrating robotics to increase speed and quality. So 3D Systems has something called the Figure 4. It's an SLA machine, but it's a cluster of SLA, and it's around using robotics and automation, and essentially it changes the robotic arm will change the build plate, it will change the material, it will clean the parts, it will test the quality. Stratasys is also looking at this continuous build 3D demonstrator. They just announced it at Rapid. And it's a multi-cell cloud-based AM platform. So again, you don't need a human. So this is really around factories of the future, 3D printers that are kind of printing without the need for anyone there. So materials. Again, it used to be that maybe there were 12 to 18 materials we talk about. But now it seems like there's always a new material popping up. We're printing in glass, we're printing in metal, we're printing in ceramic, we're printing in cement, in composites. My two favorites over 2016 and 2017 are graphene. So why is graphene so excited? Why am I so excited about graphene? It's because it's really strong. So it's 1,000 times thinner than a human hair, is how thin you can print it. It's 200 times stronger than steel. It's light, so 3 grams of it will fill a football field, and it's conductive, so electrically and thermoconductive. So lots of opportunity there. The second is Essentium. So many of you may be thinking about, well, okay, how do I know that this part may be comparable to an injection molded part? Well, Essentium just came out with some material and modifications where they essentially put carbon nanotubes on the resin or on the filament that comes out, and essentially what that does is it strengthens the Z gap, or the Z, and achieves strength of 98% as strong as injection molding. So essentially, you're getting parts that you potentially could replace with injection molding, or replace for injection molding. So quality. So America Makes is really interested in kind of what are the barriers to advancing the technology and where are the gaps. And we notice that quality and process are one of the real barriers. Making sure that the part is a good part, that it's strong, that it doesn't have any defects. And especially in metal 3D printing, where we're seeing rapid expansion really in metal 3D printing across aerospace and automotive. When you sinter metal and then you heat it up and then you cool it, you get what's called thermal distortions. So there's distortions in the part. And you have to make sure that those distortions don't affect kind of the strength and the quality of your part. And sometimes it takes 10 to 15 tries to design your part so you don't get distortions. Well, big aerospace, companies, they don't want distortions in their parts. So actually, a group of companies that are normally competitive, GE, Honeywell, and I think it was UTC, came together. And they're like, we need to solve this problem. We want parts that we know are going to have high quality. And they created a software that essentially would monitor for the thermal distortion and allow you to create parts quicker, so 75% quicker than previous, of higher quality. I would definitely say that design is one of the biggest barriers that you'll face in your organization to integrating 3D printing into your companies. And we have seen that across the board. A design for additive mindset, understanding not just how to design for manufacturing, but to design for additive and to leverage the power of that technology is critical. And I think it's about changing the mindset and asking new questions. Things like, why do things need to be solid? Why do holes have to be round? In fact, why do we even need holes at all? Why can't we print things in complete assemblies? Why do we need to even manufacture assemblies? Why can't we print things in one part? And what if we mimic nature more? And what if form follows forces? So this little guy right here, it's a 3D printed hexapod robot. We use that at America Makes to teach design for additive manufacturing because it's an integrated systems approach to understanding the system, not just design for additive, but the system around design for additive. You can take an initial design, you can start looking at movement and speed, and then you get this CAD design, and then you use all of those design elements that I talked about earlier, like lightweighting, optimization, to make the part lighter, to keep the robot moving, to keep it strong, to think about how it might start gripping things, and then to start integrating different technologies to start thinking about, well, what if we don't want wires? And what if we wanted to use embedded sensors and embedded electronics and just print this thing in one part? It's a learning tool to get you to start thinking about how you might use additive. We have a program called the Academy. It's a project-based learning experience that's very hands-on. It's built on a capstone. Right now, we're working, for example, with the Air Force, which is really interested in how to optimize engine parts. So they want to use hands-on experiential learning to figure out exactly how to optimize their engine parts. And we work with companies to think about how do you want to use additive and how can we take you through the design process to get you to that place. Who thought of glasses? Anybody? Yeah? I'm just curious. Somebody throw something else out. Somebody's got to throw something out. You. Did you think of anything? No, but you have glasses on, so. All right. Well, I was playing around with this audience participation thing, not sure how it was going to work. But, this is an example of, these glasses on the left here, the right, the left, on that side over there, are regular glasses, and those are 3D printed. They do take advantage of additive because they don't have, they're only built in one part instead of 3. But I would say my philosophy and my theory is that the true benefits of additive will really happen when we start to design things that look radically different than things that we've ever created before. So this is a chassis. On the one hand, you have a regular chassis, and this is a 3D printed chassis that uses generative design to create it. It looks radically different. So how are companies and industries using additive, and how might you think about how you're going to use additive? I think when you think about how you might use additive in your companies, the first thing to think about is not about what part am I going to produce, or how do I produce this part. It's about what capabilities am I going to develop. And it starts with the why. Why are you using it? Are you using it for innovation? Are you using it for cost reduction? Are you using it for efficiencies or inventory? So you start with the why. And then using the why, you start building your capabilities around it. Specifically what processes, what machines, what materials, how you're going to train your people. So, because people always ask me about food, it used to be that we were 3D printing sugar. This is actually a company called PicSweet. They 3D print ice pops. You can customize your ice pops if you want to customize a unicorn ice pop for your daughter or your son, or if you're in San Francisco, your wife, perhaps. And it's a platform where you can actually design the ice pops on the website, and then they make batches of 100 pops at a time. But it's professional, and it's the beginning of really seeing food actually enter the marketplace in a real professional, full productized way. On the other side of the spectrum, we have the Navy. They're interested in 3D printing specifically for repair, refurbishment, and replacement of parts on ships. Because, years go by and ship parts break, and the molds and the tools and the dies that were used to replace them were 20 years prior. So to fix them is really expensive. So how do they start using 3D printing and reverse engineering to start using it for sustainment, repair, replacement, and refurbishment of parts, and making those decisions? The next is air, so 3D printing land, sea, air, and space. Aerospace is probably the biggest place we're seeing 3D printing really take off. This was recently launched by Autodesk. It's a seat. They use lattice structure and lightweighting to redesign a seat frame. By doing that, they saw cost reduction because they lightweighted it and saw, less use of material, reduction in cost, lots of reduction over time. GE is the poster child for this. Everyone probably knows about the LEAP engine, which was a component part of the LEAP engine that kind of got them into the 3D printing space. They're looking at component parts. Over there, you'll see the heat exchanger, where they've taken 242 parts and merged it into one, built 242 parts into one build. And then we have this functional integration of an advanced turboprop engine. This one was 855 parts. And through lightweighting it and through taking out assemblies, they decreased it to 12 parts. it saw a 5% weight reduction, which turned into 20% lower fuel burn, which certainly turns into a lot of cost savings from fuel costs. And then finally, 3D printing in space. Well, many of you may know that Made in Space has sent a 3D printer to the International Space Station, and we're 3D printing tools for astronauts because a wrench might break in space, and instead of calling down to Earth and waiting 6 months for it to fly back up, they just can print it on the space station. But now we're thinking about how do we take advantage of zero gravity? Why do we need gravity? So they're looking at fiber optic cable, because it turns out that if you print long strands of fiber optic cable on Earth, they warp. The long strands warp. But if you print them in 0G and no gravity, you don't deal with warping. Now, take that one step further and start thinking about, well, what if we start sending bots out to mine asteroids for platinum and uranium and plutonium or titanium or whatever's on those asteroids, and then we use that to start manufacturing in space with these fully automated systems that use robots plus 3D printers to produce parts. We can start seeing a future that we had previously only imagined being real. So I believe the future lies in the convergence, the integration of robotics, next-generation flexible hybrid materials, AI, the Internet of Things, and 3D printing all coming together. An example of this with our sister institute is NextFlex is looking at 3D printing plus flexible hybrid materials and embedded sensors, and they're doing this for human health and performance monitoring. So essentially what they're doing is this thing has a layer. On the top layer, it's very thin material. The middle layer is a sensor, and the bottom layer essentially soaks in your sweat. The sensor then reads your sweat, and using kind of IoT, it can give you information about how you're doing. They're using this for babies, for preemies, and they're using this for warfighter pilots. Take that one step further and add robots. And just recently, researchers out of a university in the US announced that they started to print 3D printed bionic skin. So they're allowing robots to feel with this 3D printing robotic skin, which works for things like surgical planning or robots in surgery, but also allows us to think about robots interacting with each other and how these sensors might start helping them to feel. So I wanted to end by just going back to that original vision of, these local and digital manufacturing places where we could print on demand. Amazon a couple of years ago started talking about being able to print on trucks. So if you can imagine a 3D printer plus a robot in a truck can get you things on demand, and then a drone can pick that thing that was created on the truck and it can fly it, out to wherever you are. And I will end with a little Dr. Seuss poem, which is, oh, the things you can print. Can you print it here or there? You can print it anywhere. On a truck or with a drone, maybe even one day in your home. Thank you.